Hello, welcome to GED Exam Preparation class. I am your host and instructor, Ruben Herrera. And on this lesson, my friends, we are going to learn how to simplify expressions. In other words, we're going to learn how to simplify algebraic expressions or algebra problems. Okay, so whenever we simplify algebraic expressions, my friends, they're not asking us to, we're not solving for anything. We're not looking for the answer of anything. We just want to simplify. We just want to simplify problems, okay? And whenever we simplify problems, we do this by combining like terms, and we can only combine like terms. For example, let us look at this expression right here. We have 3b plus 2b. Notice that these two are like terms because they do have the same variable, and then they do have the same exponent, which is an invisible one for each one. We learned about like terms in a previous lesson, okay? So I assuming that you guys already know what like terms are. Okay, so by combining these two right here, this symbol right here, this plus, is telling me that I have to add these two coefficients right here, okay? These two bases right here, the 3 and the 2. So 3 plus 2 is equals to 5, and then the b is just going to come along for the right. So there you go. I'm just combine this expression right here. I'm just combine these two like terms, and therefore I'm just simplify this algebraic expression or this expression. Okay, remember, my friends, we're not trying to, this is not the answer. We're not trying to solve anything. We're not looking for the answer of anything. We're just simplify it, make it shorter, condense it. Okay, let us look at this other expression now. I have 7a plus 3a. Okay, are these two like terms? Yes, they are. So I am able to combine them. And this symbol right here, the plus symbol, is telling me that I have to add them. Okay, so 7 plus 3 is equals to 10, and then the variable a just come along for the right. And this is my answer. This is this expression, this right here. This is this expression right here, but simplified. Let us look at more examples now. This is just a little bit bigger. Now I have two like terms in here, the 7a and the 3a, and then I have right here the 2 by itself. So what do we do with this? This is very simple, my friends. What we're going to do, we're still going to combine these two terms by adding them, because this symbol is telling me to add these two terms. 7 plus 3 is equals to 10. The a goes along for the right. I'm just move down the a, and then the plus 2, I'm just going to move it down too. Okay, so this will be my result of simplifying this expression right here. Very nice. Let us look at one more example right here. On the next example right here, we have a minus now. We have a subtraction, and it's okay. We're gonna combine these two terms now. These two I like terms, and we're gonna combine them, but we're going to combine them by doing what this symbol is asking me to do, which is subtracting. Okay, so I'm going to subtract 7 minus 3. 7 minus 3 is equals to 4. The a comes along for the right, and the 2 comes along for the right, like so. Very nice, my friends, very nice. Okay, let us look at other different examples in here. Now I have, for example, this expression right here, the 2g minus 6g, I'm sorry, minus 2g plus 3. Very nice. As you can tell, we're going to combine these two terms. These are like terms. We're going to combine these two by subtracting them. 6g minus 2g is going to be equals to 4g, and that 3 is just going to come along for the right. Very nice. Okay. In my next example right here, I have 2g squared minus 6g. I'm sorry, I keep saying 2g. I have 6g squared minus 2g squared. So these, my friends, these are also like terms, because not only do they have the same variable, but they also have the same exponent on the variable. So I'm going to combine these two by subtracting them. But why do I have to subtract them? Well, because my symbol right here is telling me to do so. Okay, 2g is 6g is square minus 2g is square is going to be equals to 4g is square minus 3. Notice that I'm going to move down this 3 exactly the way right here. I'm going to move it down exactly the way it looks with the same symbol. Okay, let us look at our next example. Now I have 7a plus a plus 2. Okay, do I have any like terms in here that I can combine? Yes, I do. I have the 7a and the a. And remember, my friends, whenever we have a variable by itself, it is assumed that there is a invisible 1 in here, but only smart people can see it. Can you guys see it? Yes, that's what I thought. So right here, 7a plus a, which is really 1a, that's going to be equals to 8. Number 8, letter A, plus 2. Okay, very nice, my friends. Remember, whenever you see a variable by itself, it is assumed that there is a invisible 1 in there. All this is all the time. Okay, in our next example, now I have 7a minus a plus 2. So I'm going to combine these two terms right here. Now this time I'm going to subtract these two terms. And notice right here with the a by itself, notice that, remember that there is a invisible 1 in there. Okay, so that's going to be 7a minus a, which is really 1a. That's going to be equals to 6a plus 2. Very nice, my friends. Very nice. Let us look at some other examples. I believe I have some more for you. Okay. So right here, I have, this is the mother of all expressions, and we're going to have to simplify this. We're going to simplify this by combining like terms. So do I have any like terms in here? So yes, I have the 6a and the 2a, and I also have the 4b right here and that 2b right here. So I'm going to combine these two right here, the 6a plus 2a, and then the 4b plus 2b. Okay, this is going to be equals to number 8, letter 8, 8, I'm sorry, 8a plus 6b, okay, plus 3. Okay, the 3 just comes along for the right. Very, very, very nice. On my next example, my friend, same thing, but this time I have some negatives in here. So do I have any like terms in here? Yes, I do. I have the 6a square and the minus 2a square. Then I have the 2b and that 4b and the 2b in here. Okay, very nice. So I'm going to go ahead and combine these terms right here. I'm going to combine the 6a square minus 2a square, and then I'm going to combine the 4b plus 2b. And that's going to be equals to 4a square. 4a square because I am subtracting 6 minus 2, that's equals to 4. The a square goes along for the right. And then the 4b plus 2b, that's going to be equals to 6b plus 3. Very nice. Let us look at other examples in here. In our next example, I have, this is going to be a very tricky one because the answer actually may confuse you, okay? So I have right here 7a. I have these like terms in here. And then I have this, that 6a square and the 2a square also as like terms, okay? So I'm going to combine these two, the 6a plus 8, which is going to be equals to 8a, and then the 6a square plus 2a square, which is going to be equals to 8a square plus 2, and then the plus 2 at the end. However, when I write my answer, it is recommended that first I combine or write the term, combine and write the terms that have exponents, and then the terms that only have variables with invisible exponent or no exponent. And then at the end, all the coefficients or the constants by itself, in other words. So notice that so far we've been combining our like terms and writing our answers in the order that they show up, or on the order that they appear from left to right. However, Once we get in an example like this where I have exponents, they want us to always write down first the terms that have exponents right here, like this one. And then next we're gonna do the ones that do not have exponents or otherwise invisible number ones in here. And then at the end we're gonna write down the constants. Very nice. Let us look at this our next example in here, okay? So I have y squared plus y squared plus y plus y plus 1 plus 2. So first I'm going to detect again my like terms in here. These two are like terms, very nice. These also are like terms, these two right here, but they're different from the y squared because they do not have the same exponent. And then these two terms right here, the 1 and the 2, these constants, they're also like terms because what they have in common is that neither one of them have variables nor exponents. So that's what makes them like terms. So the way we will write our result, remember my friends, whenever you have a variable by itself, it is assumed that you have a invisible number 1 here. Okay, so therefore when we combine these terms, and at the end these terms right here, our answer is going to be equals to 2y squared, 1 for each of these y in here, and then plus 2y, 1 for each of these y's in here, because remember there's also an invisible 1 in here, and then the 1 plus 2 is equals to 3. Okay, very nice, very nice. I have a few more examples left. These are going to be some examples that are also going to be on your GED exam, and these are kind of tricky. Okay, so let us look at this example right here. I have the 6a minus 6a plus 4b minus 4b plus 3. So I have some like terms in here, as you can already tell, and these are also like terms. Okay, very nice right here. However, when I combine these two, notice what happened. How much is 6 minus 6? It's equals to 0. And we cannot really have 0a because that a by itself will be actually an invisible 1. So therefore, 6 minus 6, these two right here, they cancel each other. Also, this 4b minus 4b, what is 4 minus 4? It's equals to 0. We cannot have a 0b, so therefore these two also cancel each other, and therefore our answer is going to be just 3. Just 3. Very nice, very nice. Let us look at our next example right here. Now I have minus 6a squared plus 6a squared, and then these are my like terms, and then I have 4b, positive 4b minus 4b as my other like terms. Then I have the 2 right here by itself. Notice that I use these little sticks or this underline method to identify my like terms first. So as you can tell, 6 minus 6 is, or minus 6 plus 6, this is going to be equals to 0. So these two are going to cancel each other. This 4b minus 4b, and I'm combining these two, and I'm subtracting this because this symbol is telling me to. This right here, I'm adding these two, but notice that this 6 is negative. Okay, and remember when we learned about the number line, remember when we go on the number line, we go spaces forward if we're adding with positive numbers, but if we add in negative numbers, we move backwards to the left. Okay, so this is why these two cancel each other. These two also cancel each other, and therefore my answer is also going to be 2. Okay, very nice, very nice. Let us look at our next example in here. I have 7b plus b. These two are like terms. Then I have these other two like terms in here, the 6a and the 2a. Okay, and so I'm going to combine these two, and I'm going to combine these two. However, when I write my answer, my friends, this is also another tricky problem that the answer on your GED test might confuse you. So remember on an earlier example, we were told that we need to write the terms that have exponents. Well, right here, it looks like I have two pairs of like terms that they have variables but no exponents. So it'll make sense to me just to write this combine these terms and write these numbers in the order that they are appearing from left to right. However, if that is not the case and all I have is variables, or I might have even have variables with exponents right here, and if all the exponents are the same, then I need to write my terms, my combined terms, in alphabetical order. In this case, the A in the alphabet comes before the B. So when I write my answer for this problem, this is going to be equals to 8A plus AB plus 2. Now, if I happen to write this backwards, the answer will be correct anyways. But however, mathematically speaking or universally speaking, it's better that we write our terms in alphabetical order too as well. Unless, remember, you have exponents, then the terms that have exponents will always come first. Okay? Very nice. I have one more example for you, my friends. I think this lesson has been long enough. So I have this right here, y plus y right here. I have these two like terms in here. Then I have y square plus y square in here. And then I have this, the 1 right here and the 2. Okay, so I'm going to combine these terms. And remember, in this case, I'm going to write first my terms that have exponent. So my answer is going to be 2y squared. Okay, this is the result of these two. And then plus 2y, which this 2y is the result of these two. And then the plus 3 at the end. The plus 3 is the result of 1 plus 2. Very, very nice, my friends. Thank you very much for watching this lesson, and I hope you like it, that you enjoy it, and that you learn. And you guys have a great day, and I'll see you in our next lesson. Bye-bye.